combinatorics. It really means counting without counting. And the best way of counting without counting is by multiplication. If you have these items here lined up, one after the other like this, so we have 5 items in a row, and 1 2 3 4 5 6 7 items in the column. If you want to count how many items there are, you can just use the technique of multiplication where we count without counting. This is by multiplication. So if you multiply 1 2 3 4 5 of the rows multiplied 1 2 3 4 5 6 7, magically you will get 35, and there are 35 items, because multiplication is actually addition. When you're multiplying 5 with 7, which of course you have memorized it, when you multiply from the tables of 5 or 7, when you multiply 5 with 7, it means you're adding 5 7 times. It's like this: 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20, 20 plus 5 is 25, 25 plus 5 is 30, 30 plus 5 is 35. So all you do is just multiply. So by the multiplication rule, counting becomes very easy. One of the most important counting, it's called counting the number of arrangements. Counting the number of arrangements, commonly known as permutation. Special type of counting. Here arrangements are important. That means AB is one arrangement, BA is another arrangement. So there are two different arrangements. So whenever we are talking about permutations, here every single order is important. So in permutation, ordering is important. If you want to figure out how many permutation there are, so it is the law of multiplication that we can use that. Suppose there are 3 items, okay, A, B, C. You want to figure out how many times, how many ways these 3 items can be arranged. Of course you can do it by just the old-fashioned counting. One way is having A front, then we have BC, and then we have CB. So there are 2 ways, 1, 2. Then have B in front, then write AC, and then write CA, 2 more ways, so 4 ways. Then you can write C in front and write AB, and you can write BA. So we have 2 more ways, so 1 2 3 4 5 6. But this is not a shortcut. We want to count without really counting. For that, what we can do is use the law of multiplication. First one, we are taking 3 items. How many ways can we have the first one? Well, there are 3 ways. We can get A or B or C, multiplied by how many ways can we get the second one? Well, if we have taken 1 item and they cannot be repeated, so we have only 2 options, so 2. Okay, how many ways can you take the final one? Well, we have taken 2 and number cannot be repeated, so we have only 1 option, so 3 into 2 into 1, this is 6. So there are 6 ways. So if you take 4 items, A, B, C, D, how many ways? You can either do the old-fashioned way and count it, or you can use the multiplication rule. So how many ways the first one? We have 4 options for the first one multiplied. If you've taken 1 option, suppose A has been taken, how many ways for the second option? We have 3 ways for the second option. How many ways for the third option? 2 ways for the third option. How many ways for the fourth option? There is only 1 way. So this is 4 3 is 12, 12 2 is 24, 24 into 1. There are 24 ways. There is a special name for this, and we write this as 3 multiplied backwards till you get 1. It's 3 with an exclamation mark. This exclamation mark does not mean 3. No, it means 3 multiplied backwards till you get 1. So there you don't have to express excitement or something, exclamation mark usually mean that. It just means 3 multiplied backwards till you get 1, and that's how you get all the number of arrangements, counting without counting, the mathematics of combinatorics. So if you want to count arrangement, this is what you do, and this is called factorial. So we actually call this 3 factorial. We call this 4 factorial. 4 factorial. Now before I end this, I want to talk about, what about you have number of items but you want to choose only something from them. You don't want to choose all of it. For example, if you have 3 items A, B, C, if you want to choose only 2, choose only 2 out of 3 items, then how do you know how many arrangement would be? First, if you write it out, it can be A, B, or it could be B, A, 2 arrangement of this. It could be B, C, or C, B. It could be A, C, or C, A. Ordering is important. So we counted 1, 2, 3, 4, 5, 6. Or what you could do is, you can take, how many ways can you take for the first item? Well, there are 3 options, A, B, C, so 3 multiplied. How many ways do you have for the second option? We have 2 options, B and C, so 2. You stop there, it's 6. Of course, since the third item is 1, and if you multiply 3 into 2 into 1, it's also 6. It's a coincidence. So this is how you do it. An example of, how about you have 4 items. So let me do it here. So if you have 4 items, A, B, C, D, and out of these, choose 2 items. How many ways can you do that? So counting without counting. So if you want to know the permutation, the number of arrangements, first one you have 4 options multiplied by. For the second one you have 3 options, and that's it, you stop. So there are 12 ways of choosing 2 items out of 4 items. If you want to choose 3 items, then you have 4 ways of choosing the first item, A, B, C, D. Now 1 has been taken, suppose A has been taken. You have 3 ways of choosing the second item, and you have 2 ways of choosing the third item. So if you multiply this, 4 3s are 12, 12 2s are 24. So there are 24 ways of selecting 3 items out of 4 items. So this will help you to count when you are calculating the number of events. So counting is very important when you're doing probability.